محمد جاهز انت هيك. بسم الله الرحمن الرحيم. Inshallah, today we'll talk about measures of variation, and as we mentioned last time, there are 4 measures of variation, and we talked about range, or the range, and we know that the range is the distance between the largest and the smallest value. The other measure of variation is called the variance. By using the variance, we can also compute another method, another measure is called standard deviation. And finally, we'll talk about a little bit about coefficient of variation to compare 2 different data sets when we have different units or different measurements. Measures of variation give information of the spread. Spread means variability or dispersion of the data set values that you have. As we mentioned last time, the range is the simplest measure of variation, and it's computed by using this simple formula. The range is the difference between the largest and the smallest. For a specific example, if we have this data set, 1, 2, 3, up to 13, then the range is going to be 13 minus 1, which is 12. So that's a straightforward example to compute the range. Now, sometimes the range is misleading. I mean, the range can give misleading result if the data set has outliers. For example, imagine if we have this systematic data, 7, 8, 9, 10, 11, 12. For this example, the range is the maximum minus minimum is 5. So the distance between the largest and the smallest is 5. For the other data, if you look carefully, we have a gap between 7 and 10. For this reason, this data is more spread than data number 1, but each of them have the same spread, the same range, because the maximum is still 12, the smallest is 7, so that will give 5. So both have the same range, but the variability in data A and data B are completely different. So we cannot rely on the range as a measure of spread or deviation. If you look at the other one, now we have 1, 2, 3, 4, up to 5. Now the range in this case is 4, 5 minus 1. Now if you replace the largest value, which was 5, replace it by 120. So 120 is a big number comparing to the next largest, which is 4. So the range is going to be 119. Now, if you compare the range for data number 1 and the other one, 4 is nothing comparing to 119. 119 is a big number. So both data sets have minimum values here, 1 up to 5. And here also we have the same minimum and approximately the same data values, but one value is completely different and your result is completely different also. So I mean, 1 point can change the range significantly. I mean, in big difference between the previous one and the other one. So that means the range is sensitive to outliers. So far, the mean and the range, these 2 measures are sensitive to outliers. I mean, outliers affect the range as well as the mean. Now let's move to the new measure of variation, which is the most commonly used measure in statistics as a measure of variation, which is called the variance. By the way, all the formulas in this class will be given in the exam. I mean, you don't have to memorize any formula for this course. So this is the first one. We have the variance, because later on we will have complicated formulas, so you don't need to memorize any of these. So both of them, all of them will be given in a formula sheet in the exam. Now, the variance, if you look at this formula, And let's see how can we define the variance based on this notation. The variance is the average or approximately the average, because here we divide by n minus 1, not n, but so it's not exactly the average, but approximately the average of what? Of square deviations, of the values from its mean. So again, the variance is the average or approximately the average of square deviations of values, I mean of the observations you have from the mean. That will give the sample variance actually. So S squared, the formula is summation of xi minus x bar squared, and I goes from 1 up to n. N is the sample size you have. Then divide by n minus 1. Now, what's the reason by dividing n minus 1? Later, inshallah, in around chapter 8, we'll talk about degrees of freedom. And in that case, we can explain in details why we divide by n minus 1 instead of n. But also next week, we'll talk about population variance. And in that formula, you'll see that we divide this sum by capital N. So you'll see the difference between sample variance and population variance. Now, x bar is the arithmetic mean or the mean, n is the sample size, and xi is the ith value of the data you have. So this is the formula to compute the sample variance. Now, the other measure is called the standard deviation. Standard deviation is just the square root of the variance. And both of them measure the spread of the data around the mean. Now, most of the time, we use the standard deviation, not the variance, because the standard deviation has the same units as the original data. For example, imagine that we have age. And age, the unit of age is years. For example, if we compute the sample variance, and suppose the value was 6. So the unit of S square should be year square, because we squared the deviation, so the unit should be square of the original unit. But if we take the square root of 6, for example, and also you have to take the square root of this unit, I mean you have to take square root of year square, that will give year. So here the standard deviation has the same unit as the original unit. For this reason, most of the time we are using the standard deviation rather than the variance. So again, standard deviation is the most commonly used measure of variation in statistics. Standard deviation shows variation about the mean, and also the standard deviation is the square root of the variance, and as I mentioned, it has the same unit as the original data you have. Now the question is, how can we compute the sample standard deviation? If you look at the formula carefully, here we have sum of xi minus x bar squared divided by n minus 1. We have x bar, so that means first step you have to compute the mean. Next step, compute the difference between each value and the mean. So imagine that we have data points x, or random variable x, and we computed x bar. Next step, we have to compute the difference or the distance between each value and the mean. The mean, for example, is whatever is that value. So x minus x bar. So first step, you have to compute the difference between each value and the mean. Next step, or step number 2, square each difference. I mean, take this value and square it. Now it makes sense that the variance should be positive, because you squared this distance. Even if it is negative, negative square is positive. So S square is always positive. Later we'll talk a little bit about this point. After we square each value, I mean each deviation, just in step number 3, you have to add the square differences. I mean, for this column, add these values together. So we have the sum of x minus x bar squared. Finally, to get the sample variance, you have to divide this total by n minus 1. So divide this value by n minus 1, that will give the sample variance. To compute the standard deviation, just take the square root of your result in step 4. I mean, for example, imagine that S square is 36. This is the sample variance. So S equal 6. So just take the square root of that value. Now let's compute the standard deviation for a specific data set. Suppose we have sample data as 10, 12, 14, up to 24 sample data, just for illustration. Sometimes we have huge or large data set. In that case, you have to use software. Software, maybe use Excel, SPSS, Minitab, or whatever software you have. For this example, there are 8 observations. So n equal 8. So the sample size is 8. Just count these values, 1, 2, 3, 4, up to 8, so that the sample size is 8. So n equals 8. The mean or the average, add these values, as we mentioned last time, and divide by the total number of observations. That will give 16. Because if we add these values, the sum is 128. 128 divide by 8, that will give 16. So we computed the average first. Step 2, we have data. For example, 10. Take the deviation for each data value you have from its mean. So I mean 10 minus 16, that will give minus 6. And do the same for the rest. I mean for 12. So 12 minus 16 is negative 4, all the way up to the last value, 24. So 24 minus 16 gives 8. That's step number 2. So we've computed the mean, then we found, or we compute the distance between each value and its mean. And then now square each one. So x minus x bar squared. So minus 6 squared, 36, 16, up to 64, all the way down, up to 64. Now sum of these values, sum all of these values, you will get 130. So the sum of the square deviation of each value and the mean equals 130. So the standard deviation, as the formula we have, divide this value, I mean divide 130 by n minus 1. The sample size, as we mentioned, was 8, so 8 minus 1, 7. So 130 divided by 7 will give 4.3. So that's the way to compute the sample standard deviation. So again, the first step here, we have to find the deviation from each value and its mean. Then square each one, each value. Add these values together. If we add these values, the answer is 130. The standard deviation is just square root of 130 divided by n minus 1. So that will give 7. Any question? Let's move to the next one. Now this sheet compares the standard deviations for 3 different data sets. Look at data number 1, data B, data C. All of them have the same mean. The mean is 15.5. So each data has mean of 15.5. Even though the distribution is completely different from data A to B to C. I mean, the mean by itself cannot be used as a measure to describe the distribution of the data, because each one has the same mean, but actually have different spread or variability. So for this reason, we have to compute the variance in order to see which one has the highest spread or highest variability around the mean. If you look at data B, all the points are gathered around each other. I mean, there is no big difference between or big distance between these points. All of them ranges between 14 and 17. So all the data sets we have here, 3 data sets, all of them have the same average or the same mean of 15.5. Data B, for example, the data points ranges from 14 up to 17. So there is no gap between these values. So it makes sense that this data set has the smallest deviation around the mean. And if you compute the actual standard deviation, if you look at that value, it's 0.926. So it's less than 1. If you look at data number 1, data A. Now, there is a gap between this value, 13, and 16. Also, there is a gap between 18 and 21. That's why the standard deviation becomes around 3 times than the previous data set we have. Now for data C, maybe this is the worst distribution comparing to the previous 2, because there is a big gap between or big distance between 12 and 19. For this reason, the standard deviation is around 4.5. So it has the largest standard deviation. So by using the standard deviation, we can tell which one has the smallest or the largest deviation. So in general, in statistics, we report both the mean and the variance, or the standard deviation actually. You have to say that the mean is 15.5 with standard deviation 3.3. Another data set has the same mean but different standard deviation. So in this case, we can tell which one has more spread. Suppose we have curves for skewed distribution or symmetric distributions. Now, both of these distributions are symmetric. I mean by symmetric, the mean splits the data into 2 halves. This mean splits the data into 2 equally areas. Data area to the right is the same as the area to the left. Now if you look at the mean or the center, this dashed line is the same for each one. So that means the means are equal for data A and data B. So the 2 graphs have the same mean. But if you look carefully at the spread or the variability for figure number 1, the spread here seems to be narrower than the other one. The other one is wider. So data A is less spread than data B, even they have the same center or the same mean. So you can tell if the data has smaller or larger standard deviation just based on the curve you have. Just look at the distance between the vertical line, I mean the mean, which splits the curve into two areas, two equal areas. Now the distance here, this one, actually is larger than the other. So we can say that data A is less spread than data B. So by using the standard deviation, I mean the actual value, or just look at the graph, you can tell which one has more spread. To summarize some facts about standard deviation, you can see that the more the data are spread out, the greater the range, variance, and standard deviation. So if the data is spread out, it means you have large range, variance, and standard deviation. The more the data are concentrated, I mean gathered around each other, the smaller the range, variance, and standard deviation. So that's the difference when the data are concentrated or spread out. We have large values, and on the other hand, we have small values. Now, there is one case, the sample mean or the variance or the range equals 0. If the data values are all the same and maybe never happen in the real life, in reality, you never, maybe 99% the data set are not equal. I mean, the values of the data sets are not equal. But imagine that you have a data of the same values. Suppose we have 5 students or 5 children, and their age is 5, 5, 5, 5. So the average of this one is 5. Now what's the range? Minimum is the same as maximum, so the range is 0. If you compute the variance, because x minus x bar, this value minus x bar is 0, for the rest it's also 0, so 0, so the standard deviation is 0. So this is the only time you will see that these measures equal 0 if all the values have the same, and that's never happened. The other one is none of these measures are ever negative, because the range is max minus min. Negative squared becomes positive. For this reason, the variance and standard deviation is always greater than 0. So you can say a square is greater than 0 or equal. And equal just if the values are the same or are equal. Any question? So we explained range, variance, and standard deviation. Now do you think outliers affect the variance and standard deviation? We said that outliers affect the range and the mean. Now it's about standard deviation. Look at this formula again. Sum xi minus x bar squared divided by n minus 1. Now, in order to compute the sample standard deviation, we have to compute the mean first. And we know that outliers affect the mean much more than the median. Since outliers affect x bar, and s is a function of x bar, that means also outliers affect the standard deviation. So far, outliers affect mean, range, standard deviation. So in case of outliers, I mean in the presence of outliers, you have to avoid using these measures. We have to use something else, and that we'll talk later about, inshallah. So the mean is affected by outlier. Last time we said that the median should be used in this case, because the median is less affected by outliers than the mean. So outliers affect the mean much more than the median. Now what's about the range? The range is affected by outliers. So in case of outliers, you have to use another measure. That will be next time, inshallah. Let's move to another measure of variation, which is called coefficient of variation. consider we have two data sets, one for age, for example, one for age and the other one for weight. Suppose someone computed the mean and the standard deviation, and he found that the standard deviation is, for example, is 10. So 10 years, because the unit is years here. And the standard deviation for weight, for example, is 7. The weight, the unit of the weight is kilogram. Now, can you say that age data for age is more spread than weight because 10 is greater than 7? You cannot say that because you have different units. So you cannot compare the spread of the data just based on the sample standard deviation. So we need a measure that compute this variability regardless of the original units. That measure is called coefficient of variation. So coefficient of variation is a measure for relative variation, always represents in percentage, shows variation relative to the mean, and can be used to compare the variability of two or more than two sets of data measured in different units. The formula for CV, or coefficient of variation, S divided by X bar. So we have to compute both the mean and the standard deviation in order to compute CV. S divided by X bar multiplied by 100 gives the coefficient of variation. Now, for example, suppose we have two stock markets, stock A and stock B. And let's say that the average price last year for stock A was $50 and the standard deviation was 5. For stock B, the average price last year was $100 with the same standard deviations. It's 5. Now let's compare which price, which stock price is more spread than the other one. I mean, which one has big gaps between the values and the mean. I mean, which values are concentrated around each other. Stock A, price of stock A or stock B. Just for simple calculation, CV for stock A is just S over X bar multiplied by 100. That will give 5 divided by 50 times 100 gives 10%. So the coefficient of variation in this case is 10. What's about the other one? S again is 5. The average of stock B was last year was 100 multiplied by 100 gives 5%. So CV for A is greater than CV for B. That means stock A, prices of stock A are more spread than stock B. That means stock B is more stable. So the stability in stock B is more than that in stock A, because this one is less variable, less variability in the data. So in this case we can compute, we can compare different data sets. That's all for measures of variation. So we talked about range, variance, standard deviation, and finally coefficient of variation. Next topic talks about z-score. Most of the time we are talking about extreme values or extreme outliers. Now let's see how can we tell if this point is considered to be an outlier. We have some data values and you want to use the mean as a measure of center or the median. Which one you have to use? If the data set has outliers, as we mentioned, then use the median. Now the question is, how can you determine if the data set has outliers or not? There are several methods. Today we'll talk just about z-score. Later we'll talk about something else. And z-score, sometimes called standardized z-score. Standardized value or standardized score. So standardized stands for Z. More details about z-score will be in chapter 6 when we talk about normal distribution. But at least here we'll just use z-score to determine or to know if this point is considered to be or suspected to be extreme value or extreme outlier or not. To compute the z-score by data value, subtract the mean and divide by the standard deviation. That means, so suppose we have data set X or data value. For each one we can compute the score. We have data value X. Subtract its mean, then divide by the standard deviation. Now again, to compute the score, you have to compute the mean and the standard deviation, the same as CV. So this score is the distance x minus x bar, then divide by standard deviation. Now do you think, what are the signs of this score? This score can be positive, can be negative, or maybe equal 0. Because x minus x bar, if they are the same, so this score equals 0, that's only if x equal x bar. Otherwise, this score may be positive or negative. It's positive when? Now, the sign can be determined by using this distance. If x minus x bar is negative, then this score is negative. If x minus x bar is positive, then this score is positive. So when this score is positive, if the value of x is greater than x bar, otherwise this score is negative if the value of x is smaller than x bar. So this score can be positive, can be negative, can be equal 0. It depends on the value of x, the value of the point, and the average or the mean. Now, what's the meaning of this score? The z-score is the number of standard deviations a data value is from the mean. For example, imagine your score for accounting A or whatever is was 75. That's your score in course A. The average of the entire class was 70 with standard deviation 5. So your score was 75, the average is 70, and standard deviation is 5. Now look at this score. It's just 75 minus 70 divided by 5 gives 1. 5 over 5 is that. Now what's the meaning of 1? This point says that this score is the number of standard deviations a data value is from the mean. Now, your score 75 and the average was 70. That means your score is above the mean by 5 units or 5 points. Now, 5 points is what is the standard deviation. So that means your score is above the mean by 1 standard deviation. So that's the meaning of 1. So if this score is 1, that means my score is above the mean by 1 standard deviation. Now suppose your friend, she has 60 in the same class, the same course. For sure the same mean and the same standard deviation. We are talking about the same class. So here this score gonna be 60 minus 70 divided by 5, so that's minus 10. Now the difference between her score and the average is 10, and 10 is twice the standard deviation, below or above? Below. The sign is negative. Here the score is 60. The average was 70, so here score is below the mean. So you can say that here score is 2 standard deviation below the mean. So you can tell if the score is above or below the mean. Next, now we are looking to locate extreme values. I mean, if you want to examine if the data is outlier or not. Now the rule of thumb is, a rule in general, a data value is considered an extreme outlier if its z-score is less than -3 or greater than 3. So suppose you compute a z-score for a data point, and z-score, for example, for this one was 1. Now the question is, does 75 outlier or not? The rule is that if the data value is greater than 3, I mean this area, or smaller than -3, in this case the point is suspected to be extreme outlier. Otherwise it's okay. Now my z-score is 1, so 1 lies between -3 and +3, so the point is not an outlier. So it's so easy to determine if the point is outlier or not. Just look at z-score. If it is above 3, is outlier. Less than -3 is outlier. Otherwise, the data is okay. The larger the absolute value of the z-score, the farther the data value is from the mean. That means, suppose you have the z-score of 3.5 and other one is 2.5. Which one the data value is farther from the mean? 3.5. So this one is the data value is farther from the mean. So again, z-score